Okay, welcome back grade 12 seniors. Today I'm going to explain for you the lesson about chemical equilibrium, and this is your lesson 9 in term 1 required material. All grade 12 advanced can study this lesson. This is lesson 9 out of 11 chapters you have to do in term 1 exams. Now, first of all, I want you to look at these two images and tell me what is the difference between the first one and the second one. Now, as you can see in the first one, water is boiling. So I can say here liquid is becoming gas. And what will happen after a while? All the liquid will become gas and the pot will be empty. So the liquid after a while will be zero and all of it will be gas. So if I will draw this on a graph, the reactants will decrease till they become zero, the reactants as the liquid, and the products will start from zero and they will increase. This is the gas. Okay, so what's happening here in this part? Now, the first main thing I want you to observe, the difference between this one and this one, is that this is a closed container. This is a closed container, and this is an opened container. In a closed container, we have two processes happening. The liquid from here is boiling and it is becoming a gas. And again, the gas here is condensing and it is becoming a liquid. So we have two processes opposite to each other happening. The liquid is becoming gas. When the gas hits the pot cover, it becomes liquid. So I can represent this as liquid becoming gas. And then a gas becoming liquid, I will represent it by this direction. So this double arrow means I have two reactions. One reaction, liquid becoming gas, and the other reaction is gas becoming liquid. Okay, now who will be zero at the end of a reaction or after a while? Notice that the liquid will keep on doing gas and the gas will keep on doing liquid. So this reaction never stops. Who will be zero at the end? Nobody will be zero. So the reactants will decrease till they become constant, and the products will increase till they become constant. So notice the difference between this reaction and this reaction. This is a one direction reaction. The reactants will be zero and the products will increase, while here nobody will be zero. Reactants will decrease till they become constant and products will increase till they become constant. Now, what is the rule for having this double arrow? First of all, I need to have a closed container. Second condition is I need to keep the temperature constant. I should not cool it down or I should not make the temperature more. So the temperature should be constant. Number 3, I have to make sure that no reactants or products escape. This means that I have to have a cover that is very well closing the container. And this happens in your kitchen. Whenever you are keep cooking something that you want the water not to evaporate, you might put aluminum foil on the top to cover it very well. So you need to make sure that no reactants, no products are escaping. Okay, number 4. What happens in this reaction? The reactants and the products become constant. Okay, and now let me insert a page and show you. Now sometimes I might have a reaction that is going from reactants to products, and then you can see big arrow, small arrow. Sometimes we do reactants to products. The forward is small and the backward is larger. And another case, we have the arrows are of equal length. What does this case mean? This case means that the forward reaction is more than the backward reaction. This case means the backward reaction is more than the forward reaction or faster. But when I put the double arrows equal, this means that the forward reaction is equal to the backward reaction. I can represent this by saying rate forward is equal to the rate backward. F means forward, B means backward. So I should put in this lesson arrows equal. If you remember, the title of the lesson was chemical equilibrium. Equilibrium means there is something equal. What is equal at equilibrium? What is equal means the rate forward is equal to the rate backward. Yani the forward reaction goes in the same rate as the backward reaction. Liquid becoming gas, gas becoming liquid, liquid becoming gas, gas becoming liquid, which means nobody will be zero at the end of the reaction. Okay, same thing is shown here in equilibrium. We have the reactants, they decrease till they become constant, and the products, they increase till they become constant. Now, I have these two reactions. H2 plus Cl2 gives me 2HCl, and 2HCl gives me H2 plus Cl2. Can I combine these two reactions in one reaction? Okay, I will start with this. H2 plus Cl2 gives me 2HCl. Now, the opposite is 2HCl gives me H2 plus Cl2. I will represent it by this arrow. So double arrow means two reactions, one reaction in the forward direction and one reaction in the backward direction. I say the reaction is reversible. Reversible means it can go forward and it can go backward. So now I want you to tell me what's the difference between this graph and this graph. Now in this graph, the reactants start from a number till they become zero, and the products start from zero and they increase. So how can I write this reaction? Reactants, one arrow products, because the reactants are becoming zero and the products are increasing. What about here? Here the reactants are decreasing till they become constant, so they are becoming products, and the products are increasing till they become constant, but nobody is becoming zero. Like reactants is not becoming products and they are not becoming zero, so I will put double arrow. So this is the difference. This reaction goes in only one direction, but this one goes in two directions. Now there is a very important time on the x-axis that you need to identify. This time is after which the reactants and the products become constant. Okay, لاحظوا إنه after this line, I think it should be here. After this line, the reactants and the products become constant. I will call this time TEQ. TEQ means T is time, EQ means equilibrium. So this is the equilibrium time. What happens at equilibrium? At equilibrium, the reactants become constant and the products become constant. So both reactants and products are constant. I want you now to make sure that you understand this point. Reactants and products are not equal. Reactants are here more than products. So reactants and products are not equal, but they are constant. Okay, there is a difference between constant and equal. Now, I want you to look at this graph, and from the graph, I want you to tell me what is the reaction represented here, like what are the reactants and what are the products. Now, as you know very well, the reactants start from a number and they decrease. So here I have two reactants, the blue, H2, and the red, N2. Now, the product is the one that starts from zero at it increases NH3. Now, do I need to put one arrow or double arrows? طبعا reactants are not decreasing till they become zero, so I will put double arrow. Now, what does this dotted line represent? Notice that after this line, all the reactants and the products are constant, so I call this line TEQ, time of equilibrium. Okay, now what is the meaning of dynamic? When I say equilibrium is dynamic, dynamic is the opposite of static. Okay, static means stays in its place, it does not move. Dynamic means move. Okay, one time the students got a question in the exam saying at equilibrium the reaction stops. Is this true or false? طبعا, this is false. Why? Because at equilibrium the reaction does not stop. It keeps on going forward and backward with the same rate. So at equilibrium, the reaction does not stop. Liquids keep on doing gas, and gas keep on doing liquid. Liquid to gas, gas to liquid. But the arrows should be equal. This means the rate of the forward reaction is equal to the rate of the backward reaction. Equal arrows. Now let's look here. The reactants decrease and the products increase. Now can you tell me where is the time of equilibrium? The time of equilibrium is almost here when the reactants and the products become constant. Now let's look at this question. Write the reaction represented in the above diagram. Now I want you to pause the video and to answer these 4 questions before I answer them for you. Okay, now the ones that decrease are reactants. The one that increase is a product. So the reactants are H2 plus I2 and the product is HI. Now do I need to put 1 arrow or 2 arrows? طبعا reactants are not becoming 0, so I will put 2 arrows. What does the dotted line represent? Notice that after this line, everybody is constant, so T equilibrium. What is dynamic? Dynamic means keeps moving forward and backward. What happens at equilibrium? At equilibrium, rate forward equals rate backward. Equilibrium means equal. What is equal? Rate forward equal rate backward. And reactants and products are constant. So remember, these 2 things happen at equilibrium. Reactants or products are constant, and the rate forward is equal to the rate backward because equilibrium means there is something equal. طيب هلا conditions for equilibrium. أول إشي we have to have closed container, constant temperature, and all reactants and products are lost, so that's why we use a closed container so that nobody escapes. Now this is a question that is important in the exam. You have this particle diagram and you have to tell me when is equilibrium reached. When is equilibrium reached? You have to tell me the time. Here the time is 0. Here the time is 17. Here the time is 32. And here the time is 47. At what time of these 4 is equilibrium reached? As you know very well, at equilibrium, the reactants and the products become constant. So I will see when reactants and products are constant. طبعا the reactants are H2 and I2. And the product is HI. Now let's count. H2 is this white. 1, 2, 3, 4, 5, 6, 7, 8. I2 is the gray. 1, 2, 3, 4, 5, 6, 7, 8. HI is 1 gray and 1 white. Here we don't have HIY because the reaction just now started. Now let's see the whites. 1, 2, 3, 4, 5, 6. The grays 1, 2, 3, 4, 5, 6. And this is 4. Okay, now let's see this one. 1, 2, 3, 4. 1, 2, 3, 4. And this one is 8. Now what do you notice? We notice that H2 is decreasing, طبعا because it's a reactant. I2 is also decreasing because it's a reactant. HI is increasing because it is a product. Now let's see here. 1, 2, 3, 4. 1, 2, 3, 4, and 8. So when did the reactants and products become constant? After this point. So this is the time where equilibrium is reached. Okay, so whenever they become constant, this means equilibrium is reached at this point. Now this is a question in your topic questions. The question is, at what time does the reaction first reach equilibrium? طبعا when the reactants and products become constant, I think it is after T4. Now here also, when does the reaction reach equilibrium? I think it is at 9. Now again, when does the reaction reach equilibrium? At 5. Some students get confused and say it's 1. At 1, nothing happens. Even if they coincide, they intersect here, nothing happens at 1. When they become constant, when products and reactants are constant, this is the time of equilibrium. Okay, so the reactants here and the products are constant. Now what is the equilibrium? Now we finished with the theoretical part. Let us start with the calculation part. Okay. The equilibrium position is a particular set of equilibrium concentrations. Now I will show you how do we use the equilibrium concentrations to calculate the equilibrium expression. Okay, pause the video and answer this question. Okay, now types of equilibrium. We have two types of equilibrium. The first type is homogeneous. Okay, and the second type is heterogeneous. Now, what's the difference between this one and this one? In homogeneous reaction, I can see only one state. One state, يعني all of them are in one state. يعني like this one, gas, gas, gas. All of them are gases. This is one state. This is homogeneous. Now, in heterogeneous, we can see two or more states. Okay, in heterogeneous, we can see two or more states. Like here, we have gas, we have solid, we have gas and gas. So we have two different states. So this is heterogeneous. Remember, homo is one state. Hetero is two or more states. Okay, so here we can see two or more states. This is heterogeneous. طيب, let's do a question. Now look at this reaction and tell me which one of these is homogeneous, which one is heterogeneous. Pause the video and answer the question. Okay. Yellow, now pause the video and answer the question. Okay, be careful. The concentrations of reactants are equal to the concentrations of products? طبعا لا. As I said before, two things happen at equilibrium. Reactants of products are constant. They are not equal. And the rate forward equal rate backward. Okay? So here the concentrations of reactants are equal. No, they are not equal. Now, how do we write KEQ? KEQ is called the constant of equilibrium. Okay, so KEQ is called the constant of equilibrium, or you can say equilibrium constant. Okay, now in order to write the equilibrium constant, you need to remember three things. Thing number one, if you have solids and liquids, you cancel them directly. Number two, you do products over reactants and not reactants over products. Be careful. Number three, if there are coefficients, you make them powers. Okay, let me give you an example. If you have this question, 2A gas plus B solid is in equilibrium with C liquid plus 3D gas. Now I want you to write for me the KEQ expression, okay, KEQ. Remember, solids and liquids should be cancelled. So who will be cancelled? This solid and this liquid. Second thing, we write products over reactants. KEQ equal products over reactants. What are the products? D, 3D. The coefficient will become power. So this 3 will be power. So I will say D power 3 over reactants. طبعا B is cancelled. So we have only A. We will not write 2A. If you write 2A, this is wrong. 2 is the coefficient. It becomes power. So it will be A square. Okay, هلا if I gave you the concentration of D and the concentration of A, you can put the numbers and you can calculate KEQ in numbers. Okay, يلا, another question. First of all, let's look at these questions and see who is homogeneous and who is heterogeneous. Now this one have solid, solid, gas, so this is heterogeneous. This one solid, gas, also heterogeneous. This one liquid, gas, heterogeneous. This one liquid, gas, heterogeneous. This one gas, so this is homogeneous. Okay, can you pause the video and write KEQ in each question? Okay, remember that we usually cancel solids and liquids. So this solid will be cancelled, this solid will be cancelled, so we will have CO2. So the products are CO2 Okay, I don't have any reactance, so I will say over 1. Okay, if no reactance means over 1. Be careful, you cannot say over 0 because this will give you infinity. Okay, type now. Also here we will cancel the solid. What is left? Product CO2 over reactance CO. Now this one also cancel the liquid. So we will have this one, C2H5OH over 1. Okay, here this will be cancelled. So here we will have 2H2. Be careful, this is a coefficient. It will be power. So I will say H2 square times O2 over, no reactance, so over 1. Here nobody will be cancelled because all of them are gases. So I will start with this. 4NO will be NO power 4. 6H2O will be H2O power 6 over NH3 will be NH3 power 4 and O2 will be O2 power 5. Okay, now very important question. You are given this KEQ expression and you want to write the chemical reaction that corresponds to this KEQ expression. Okay, now this is the product and this is the reactant. So the product is NH3 and the reactants N2 plus H2. Now be careful, these powers were coefficients. So this will be 2 NH3 and 3 H2. طبعا because this is equilibrium, I will put double arrow. Now what I want from you, I want you to calculate KEQ. Now KEQ is equal to NH3 square over N2 ضرب H2 power 3. Now you have to calculate the value of KEQ. طبعا NH3 is 0.933 square over 0.533 ضرب 1.6 power 3. Okay, and then you calculate the value of KEQ. Now let's see another question. Okay, take 5 minutes. Sorry, 5 minutes is too much. Take 1 minute. Take 1 minute to write the KEQ for this reaction. First, is this equilibrium homogeneous or heterogeneous? Okay, gas, gas, gas. So this is homogeneous. When we say homogeneous, is there anything to cancel? Is there any solid or liquid? No. So can you write KEQ expression? Okay, remember products over reactants. PCl3 ضرب Cl2 over PCl5. Okay, now I want to calculate it. KEQ equal PCl3 is 0.135. Cl2 is 0.55. PCl5 is 0. PCl3 is 0.55. Sorry, this is a mistake. 0.55 over 0.135, and then you calculate KEQ. You don't have to worry about the unit of KEQ. Now, is the value of KEQ significant? Like if you got KEQ more than 1 or less than 1 or equal to 1? You might get KEQ more than 1 or KEQ less than 1 or KEQ equal to 1. When KEQ is more than 1, this means that P over R is more than 1. This means that P is more than R. يعني here in this case I say products are favored. If the products are favored, do you think the reaction likes to go forward or backward? Products are favored, so the forward reaction is favored. Okay, if KEQ is less than 1, now P over R is less than 1. This means that P is less than R. Now who is favored? Reactants more than products. So I can say reactants are favored. يعني reactants مفضلين. So the reaction loves to make reactants. So the reaction likes to go backward باتجاه reactants. When KEQ equals 1, P over R is equal to 1. يعني P equal R, يعني nobody is favored. Now I will show you how does the graph look like when I have this graph and I draw the reactants. Now the products are more than reactants, so I will take the graph up. Here in this case, okay, this is the reactants. Products are less than reactants, so the products will be here. Okay, here in this case, these are the reactants. Now the products are equal to reactants, so the products will increase and they will go together with the reactants. Okay, so these three cases are very important. If after you calculate KEQ, you can tell who is favored, if products are favored or reactants are favored. Now, this is also a question in your practice sheet. You can solve. Try to write the expression. طبعا this is homogeneous. No need to cancel anything. Write KEQ is equal to P over R. Remember, these coefficients become powers. And write the expression. Pause the video and answer. Okay, as you can notice here, when you calculate KEQ, this is 12.5. Is this number more than 1 or less than 1 or equal to 1? This is more than 1. يعني products more than reactants. يعني the reaction prefers to go forward to make more products. إذن you will find this is more than this. Okay, go read this. I already explained it. Okay, now let's look here. Who is more in this question, reactants or products? Reactants are these two colors, and the product is this. Notice that we have 1, 2, 3, 4, 5, 6, 7, 8, 9 products, and this is 1 and this is 1. So who is more? Products are more than reactants. Here we expect K to be a large number. K should be more than 1. Now let's look here. We have the grays are the reactants and these are the products. So we have two products and the reactants 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Who is more? Reactants are more than products. So here I expect K to be less than 1. Okay, now we spoke about homogeneous and heterogeneous expressions already. Now let's do this question. First of all, I want you to tell me, is this reaction homogeneous or heterogeneous and why? Second thing, I want you to write KEQ expression. And last, I want you to calculate KEQ. Okay, يلا. Pause the video and do this question. Okay, now let's do another question. So the answer should be 0.20. I think there is a mistake here in this one. This one is not correct. Okay, now what happens when I reverse the reaction? Okay. Yeah, before we continue, let's do this. We have this KC, we have this reaction. Is this reaction homogeneous or heterogeneous? طبعا all of them are gases. This means it is homogeneous. Okay, now I want to write KEQ expression. P over R. NOBR, remember that this 2 will be power over N2. This is not plus, this is times. BR2 times O2. Now Kc is given 2 times 10 to the minus 27. This number is a very small number. This is less than 1. يعني who is favored? Products less than reactants. يعني reactants are favored. Now, what happens if I reverse a reaction and what happens if I multiply a reaction by a number? If you have 2A, طبعا gas, in equilibrium with B gas, and here the K is equal to 5. Now, if I reverse the reaction, which is B gas in equilibrium with 2A gas, Now, what is the KEQ here? KEQ is P over R, which is B over A square. Now, what is the KEQ here? P over R, A square over B. لاحظوا إنه here B is numerator and here B is denominator. Here A is denominator, A is numerator. So we flip the fraction. So if K here is 5, this K will be 1 over 5. So the rule is if we reverse the reaction, we flip K. So K will be 1 over K. Okay, unlike delta H. Delta H, when we reverse the reaction, it will be negative. But here, no, we flip the K. Now, what happens if we multiply a reaction by a number? Like, let's say I have A gives me B, and the K is 10. Now, 2A gives me B. How much is K? طبعا, what did I do with this reaction? I multiplied this reaction times 2. You know that coefficients, what do they become? Coefficients become powers. So this 2 will be power. So it will be 10 power 2. Okay, so the answer is 100. So if I multiply by a number, it will be a power. Okay, remember these two rules for calculating the K. Okay, now calculate Kc for the reverse reaction. If I reverse the reaction, what is K? K will be 1 over the old K. 1 over this one. 2 times 10 to the minus 27. Now calculate Kc for this reaction. Now this reaction is this reaction, but we multiplied it by 2. So 2 will become power. So the new K is equal to 2 times 10 to the minus 27 power 2. Okay, so this is the way we calculate. Now take few moments to go through this question and answer it. Okay, let's see if we have more questions. Okay, yalla, let's answer this question. You have this equation. طبعا this is homogeneous. What is the equilibrium constant expression and calculate it by using these values. Please pause the video and go through the question. Okay, and then you find the answer and you don't worry about the unit of K. Okay, now I think we just now solved this question. Okay, now this is the end of your lesson. Few points to remember. At equilibrium, what happens at equilibrium? At equilibrium, we should have closed container. We should have constant temperature. We should have reactants products are constant. And we should have rate forward equal to the rate backward. Now, how do we calculate KEQ? KEQ, number 1, cancel solid and liquid. Number 2, products over reactants. And number 3, if there are coefficients, you make them powers. Okay, now if KEQ is more than 1 or less than 1 or equal to 1. If KEQ is more than 1, this means products are more than reactants. KEQ is less than 1, this means products less than reactants. KEQ equal to 1 means products equal reactants. The last thing if you need to remember, if we reverse a reaction, K is equal to 1 over K. If we multiply by N, k is equal to the old k power n. The number becomes power. Okay, now this is a summary of all the equilibrium lesson. I hope this video was beneficial for you and you learned something new. We have 2 more lessons. I will be uploading 2 more videos and then we will be done.